What is the instantaneous rate of reaction? And how to determine it? So I actually like this description a lot in regards to it. Here it says the instantaneous rate of reaction is defined as a change in concentration of the species per time in a specific time given. So if you think about it, it's kind of like, it's not kind of like that at all. I would say more so because if the concentration was decreasing at a constant rate, then the instantaneous rate would equal the constant rate. But typically in the world, what happens is that as more and more product is produced or reactants is lost, because there's less things to collide with each other, the reaction usually, instead of being a straight line like that, it actually kind of goes more like this, where it balances and levels off because of the fact that there's a change occurring in regards to the products and the reactants. Okay, so this is typically what we get. So in this case, the instantaneous rate will be different than just the rate of reaction, because the rate of reaction isn't constant, it's changing over time. What the instantaneous rate does is get a specific rate at a specific time. The way you do that is you need to draw a line tangent, so it intersects only at one point, but it has to be tangent to the rate of reaction. So if I drew a line that so we have the 1 point there, and I guess the best line would be something that goes like that, to where it only touches that point. We can use this line, the rise over run, to figure out the instantaneous rate of reaction at this specific time. So at this time, let's say this was time 5 seconds. At 5 seconds specifically, so 5 seconds, that would be the specific instantaneous rate, specific only to that 5 seconds. You couldn't say that was just going to be the same instantaneous rate if it was like 10 seconds, which is like down here. This would have a different instantaneous rate because it will have a different tangent line. So like something like goes like this. So different tangent line, which is why it would have a different rate. Okay? So with that being said, the goal here is that the instantaneous rate of reaction is the specific rate of reaction at a specific time given, and then how you determine it is by drawing a linear line tangent to your rate of reaction, but it has to intersect at one point, and that point will be, in a sense, your rate at that specific time. And then you find the slope of your linear line, and that will be your instantaneous rate. Okay? As you can see here, that's what they did. They drew a line tangent to it. They got the rise over run, and that is how they're able to find specifically their instantaneous rate at that specific time. Okay? So with that, this is correct. Now let's move on to the next question. Question number 5.